Hey guys, so today we are going to be doing some applications of trig functions. So the first thing we're going to do is review a bit of right triangle trig, okay? So the first couple examples, what we're going to do is we are going to solve the triangle. So when you see solve the triangle, that means that you want to find all angles and all sides. So let's see what we have here first. So notice I already give you a triangle, and so I'm going to label it with the information that we know. So let me see if I can get zoomed in a little bit more. There we go. So right here at angle A, I know this is 54.8 degrees. Notice we already know that this is 90 degrees. And C over here is 80. So from this information, we're going to solve the triangle, which means we're going to find the missing angle and the two missing sides. So let's start off with that missing angle first. So we should all know that a triangle has 180 degrees. So angle B is going to be 180 minus 90 minus 54.8. And that is going to give us 35.2 degrees. So I'm going to come over here and I'm going to label that 35.2 degrees. Okay, let's just go ahead and start with A. So I personally like to try to use things that were given to us, because when we find things, we typically have to round. And so I want to make sure that there's no type of error. So I'm going to be looking at sine of angle A, which is 54.8. So remember that is opposite, which is going to be A over 80. Now remember, when the 80 is on bottom, you can think of this two different ways. We can sit here and multiply both sides with 80, which is technically the more correct way, and cancel that out. But a little trick is we're just going to cross multiply, and that gives us what A is. So either way, we get 80 times the sine of 54.8, okay? So we need to figure out what A is going to be. So the one thing I would like for you to do is I would like for you to make sure that your calculator is in degrees, because if your calculator is not in degrees, you won't get the right answer. So if we take 80 times the sine of 54.8, we should get 65.30, two decimal places, so we'll go 37. Okay, so that means side over here is 65.37. Okay, so now we got to find B, and so in the relationship to angle A, we're going to be dealing with cosine. So cosine of 54.8 equals B, which is adjacent over hypotenuse. So again, the B's on top, so I just need to multiply 80 times the cosine of 54.8. So 80 times cosine of 54.8 gives us 40. Oh, I typed mine in wrong. I was like, oh no, that does not match. I accidentally hit the 5. There we go. So B would equal 46.11. So we have just solved the triangle. Okay. Okay, so it's up to you. If you would like to pause the video, go ahead and do this next example. If you don't, we will start it together. Okay. So we're solving right triangles. Normally one of these is A, one of these is B, and typically this is C. And then across from them are your little letters for your sides. So I know that A, so this one over here, is 11.2. And I know this one over here is 65.8. So we need to start finding everything. So we have two sides and we're missing one. So I think I'm going to use the Pythagorean theorem. So I'm going to have 11.2 squared plus b squared equals 65.8 squared. So this becomes 125.44 plus b squared. I have 4329.64. Subtract, we get 4204.2. And then when we square root both sides, we get 64.84. So b right here would be 64.84. Okay. Let's start with angle A. So to figure out angle A, I'm going to have opposite over hypotenuse. So sine for angle A is going to be equal to 11.2 over 65.8. So remember, we can do our inverse on this, which means I go from finding a side to finding the angle. So I'm going to hit shift sine 11.2 divided by 65.8. So I get that my angle A is 9.8 degrees. Okay, and then we know that this one's 90. So for angle B, we're just going to do again 180 minus 90 and minus 9.8. So when we do that, we find out that angle B is 80.2 degrees. So this one up here is 80.2 degrees. Okay, so just remember, if you're asked to solve a triangle, you got to find everything. And please know that you can solve this many different ways. You could have found angle A and then use that to help you find side B. Your answers could just be slightly off due to round off error. But yeah, you can solve these many different ways. Okay, let's go to another question. So a police helicopter is flying 800 feet. A stolen car is sighted at an angle of depression of 72. Find the distance of the stolen car to the nearest foot from the point directly below the helicopter. So sorry. Okay, so notice you have your angle of depression, but the angle of depression plus this little bit makes a 90-degree angle. So I know that this is 18 degrees. So if you need to, look at your triangle. You are given of this angle. This is considered opposite, and then this would be considered adjacent. So to get that angle, I'm going to go ahead and write it. We did 90 minus 72, which is 18 degrees. And then the trig function that deals with opposite over adjacent is tangent. So tangent of 18 degrees equals opposite over adjacent. Now remember, when the unknown's on top, we just multiply. So 800 times tangent of 18. So 800 times tangent of 18 degrees. And we get 259.936. It says to the nearest foot. So we're going to say approximately 260 feet. Okay. Let's look at the next one. From a point on ground level, or level ground, 300 yards from the base of a building. Okay. We have an angle of elevation. So we got it. Something's going on over here. We got a building over here. We have an angle of elevation. To the top of this roof is 38.7 degrees. and we're trying to find the height of the building. Now notice what it says right here. It says to the nearest foot. So I'm trying to figure out how many feet it is over here. Feet question mark, okay? But notice what it gives us, 30 yards. So we need to convert that. So 30 yards, okay? How many yards or how many feet are in a yard? So in 1 yard, we have 3 feet. So yards cancel, 30 times 3 is 90 feet. Okay. So we're given opposite over adjacent. So that's tan again. So we're going to have tan 38.7 equals, we'll just call it h for height, over 90. Again, we're going to cross multiply. So 90 times tan of 38.7, we get a height of 72.104. So to the nearest foot, so that would be 72 feet. Okay. Let's see what we got going on next. And I would personally try to maybe draw some of these before I do and kind of see if you can draw them correctly, because sometimes it's just the interpretation of the question, but you know how to do the math. Okay. A building that is 200 feet high casts a shadow of 400 feet long. Find the angle of elevation to the nearest 10th degree of the sun at that time. So we got a sun, and we got a building. It's casting a shadow, and that shadow is 200, hold on, the building is 200 feet, the shadow is 40 feet. And this is 250 feet. Find the angle of elevation. Okay, so looking at our angle, again, we're given opposite and we're given adjacent. So tangent of whatever angle this is equal to 250 over 40. So to find the angle, we do inverse tan of 250 over 40. So inverse tan of 250 divided by 40. So theta is going to be equal to 80.9 degrees. Okay. Okay. So now we're just looking at some triangles. It says find the length x to the nearest whole unit. Okay, so x is up there that we're looking for. So, do you notice that we have, well, let me just do it in pen because that highlighter is really thick. Do you notice that we have two different triangles here? This first triangle here has 28 as the reference. So that would allow us to figure out what the height is right here. So let's see. That would be tangent again. So we're going to have tangent of 28 equals k over 400. And again, when that's in the bottom, we just multiply. So 400 tan of 28 is 212.684. I know it says round to the wholest unit, but I'm going to wait because I don't want any round off error. So that means that this is 212.684. But then what I want you to notice, we have this larger triangle. And that has a degree of 40. So that means, again, we're going to have tan of 40 is equal to 212.684 plus x. So these together make the length of all of that over 400. So we already know that the top is equal to 400 times tangent of 40. And that looks to be 335.640. And then we're going to subtract that from both sides. So we get 122.956. So now we'll round to the nearest foot. So it looks like that would be, or the nearest unit, 123. Okay. So notice that this next one is kind of the same thing. So if you want to pause the video and give it a try yourself, please do. Okay. So again, we have a small triangle right here. So we're going to figure out what that length is right there. So again, we have tangent 48 equals 500 over c. So notice it changed. So we still can multiply by c like we always did, but notice what's going to happen. To solve for c, we're going to have to divide by tangent of 48. Okay, so that's a lot of work every single time you go to do these problems. So I want you to try to see the relationship between the two. Okay, these just switched. Okay, so that means when it's in the bottom, we're going to get c equals 500 divided by the tangent of 48. Which gives us 450.202. Oops, I did forget to highlight that 48. There we go. Okay, so now we're going to look at the triangle with the 20 degrees. So, we've still got our 500, but now this length is both of them together. And so we had said that this C is equal to 450.202. So we're going to be combining them. So again, we're going to have tangent of 20 equals 500 times x plus 450.202. So if you want, you can still do that same thing. We can switch these. So 500 divided by the tangent of 20 is 1373.739, and then we're going to subtract 450.202. So that gives us 923.537. So we could say that x would be, so to the nearest would be 924 for that one. Okay. Okay, we got back to a word problem. So a flagpole is situated on the top of a building. So we got a building. And then we have a flag. Okay. The angle of elevation from a point on the ground is 330 feet from the building to the top of the flagpole. So we go out here 330 feet into the top of the flagpole. We have an angle of elevation that is 63 degrees. However, we have from the bottom, we have that this is 53 degrees. Okay, find the height of the flagpole. Okay, so we're trying to find just the height of this. So let's see what all we have going on. So if we were to look here on this first triangle, okay, we'll just call this a K. So for this first triangle right here, we would get tan of 53 equals K over 330. So K equals 330 times tan of 53. Oops, typed it. It would help if I type it in, right? So we get 437.925. And I'm going to put that out here. So 437.925. Okay. Then we have our other angle of elevation. But this one goes to the big triangle. So all the way up to here, here, back over here. So that is allowing us to find the whole entire thing. So we'll call that C. So tangent of 63 equals C over 330. So that means C is equal to 330 tangent of 63. So we get C to equal 647.661. So the whole entire thing is 647.661. So therefore, if we would just subtract them, so 647 point, we'll just call it 7, minus 437.9, we would get 209.8 feet. So that is what the height of the flagpole would be. Okay. Okay, next one. So the last concept that we're going to go over is bearing, and bearing is used in sorry, my brain just stopped. Like in ships, airplanes. Okay, so it's another way to inform people of a direction that you're going. So one thing that I want you to write is, I'm going to switch colors real quick. Okay, bearing, remember it is always red from north or south. So I want you to look at all the ones that we have here. This is your north to south line. Okay. And then it's up to you how you want to look at it. But it's never eat sour watermelon, never eat soggy Wheaties. But you're always going to have that north to south line. And then your east and west line. Okay. So here we go. So notice that this one says the bearing from O to P is north. Well, first of all, it's north because it's coming off the north line, 40 degrees, but it's headed towards that east direction. Okay. So notice the next one. It's the bearing from O to P. It's coming off the north line, 65 degrees, but it's headed towards the west direction. This one is coming off the south line. So it's south 70. It's the distance or the angle off the south line, and it's going towards the east direction. Okay. Okay, so let's look at the few examples right here. So this one says find the bearing from O to B. Well, O's in the middle, B's right here, so I'm coming off this direction to get there. Well, we know that this will make 90 degrees. And then if I already know that the other angle is 60, then the angle I'm coming off is 30 degrees. So we're going to have north 30 degrees, and I was on the west side. Okay. So the next one, the bearing from O to D. So O's here, D's here. Same thing. I know that this is going to make a 90 degree, so it's 90 minus 35, which means we went off 55 degrees right here. So I'm going to have the south line, so it's south, 55, and then east, because I went on the east direction. Okay. Okay. So let's go look at some word problems. A boat leaves the entrance to a harbor and travels 40 miles on a bearing of south 64 degrees east. So let's think about it. We have our north and we have our south line. Somewhere in here is our east and our west. Okay. So the boat leaves the harbor. So the boat's coming this way. 40 miles. So we have a little boat here. Not a very good artist, but it works. Okay. I knew to draw it here because it had a bearing from the south of 64 degrees towards the east. So probably should draw this a little bit longer. So it's wanting to know how many miles south did I go, and then how many miles east did I go. Okay, so if I kind of continue drawing this, I know it's a little off, but it's okay. It's wanting to know how many miles south, how many miles east. So let's go ahead and start with how many miles south. Okay, so south right here, for looking for that question mark. Hold on, my pen won't click off. There it goes. Let's just call this, we'll call this a C. Okay, so that would be, this would be adjacent, and this would be hypotenuse. So we're going to have cosine of 64 degrees equals C over 40. It's on bottom, so we multiply. So 40 times cosine of 64. So 40 cosine 64. We're looking at 17 point, doesn't have it, so let's just say 5. Okay. So this would be 17.5 miles south. So then it wants to know how far east it went. So we're talking about this line. So now this is opposite and hypotenuse. So we're going to have sine of 64 equals k over 40. So k equals 40 sine of 64. So it looks like it would be 35.95. So we're just going to call that one 36. And then I'll say and 36 miles east. And there's our answer. Okay. Okay, let's look at 56. A ship is 9 miles east and 6 miles south of a harbor. What bearing should be taken to sail directly to the harbor? Okay, so let's see what's taken off. So let's just say, here's our north and south line. East and west. And I am just going to write harbor is right here. So we have some ship, and it is 9 miles east. So it's 9 miles east, 6 miles south. So this would make like a triangle. So we have the ship right here. Okay. So we got to figure a few things out here. Well, first of all, that makes a triangle. So we're able to figure out what degrees that is. So let's just call that theta. So this would be opposite, and then this would be adjacent. So we're looking at tan. So we would need to do the inverse of tan to get that. So shift tan 6 divided by 9. So 30, let's just call it 33.7. Okay. So let's see what's going on here. So we know that this makes 90 degrees. So let's see if we can figure out what this would be here. So we have 90 minus 33.7, and that gives us 56.3. So I know that this has a 56.3 degrees here, and then I'm going to go ahead and write this one here as well. Okay, so let's see what the question is actually asking. So it's saying, what bearing should be taken to sail to the harbor? So what bearing would the ship need to take? Well, let's rethink about it. The ship's right here. So this would be north. This would be south, east, and then west. Okay. So a bearing, remember, it comes off the north line. So I need to know what angle that is. Well, technically we've already found it. So there's a couple different things you can do here. From geometry, high school geometry, you have two parallel lines and a transversal. In the inner ones, alternating interior angles are the same. Or you can also think of it as a triangle. So we would do 90 minus that 33.7, which still gives you 56.3. So notice we're coming off the north line, 56.3 degrees, and we're going west. That would allow this ship right here to follow this line directly back to the harbor. So that is the direction that the ship would need to take. Okay. Okay, I think we got one more. Okay. see what we got here. A ship leaves the port with the bearing of south 40 degrees west. After traveling 7 miles, the ship turns 90 degrees and travels on a bearing of north 50 degrees west for 11 miles. At that time, what is the bearing of the ship from the port? Okay, so we got a lot going on here. So we have a north, we have a south, east, west. Okay. So the ship leaves the port. So this is the port. Okay. Southwest of 40 degrees. So I'm just going to draw this line out. This is your bearing of 40 degrees, and we're southwest. Okay, so that takes care of this direction here. Oh, by the way, it said it traveled 7 miles. Let's get my 7 on there. So this is 7 miles. So let's just say it stopped right here. So hold on, let me see if I can. We will just draw the ship. Okay. Okay. Then it turns 90 degrees. Okay, turned 90 degrees. And travels on a bearing. So here we go again. We got another bearing. I'm just going to go ahead and draw this up high. So north, south, east, west. And travels 50 north, so this means this is 50 degrees, and it travels for 11 miles. So now let's say oops, I can't draw my beautiful ship. Hold on. Okay. At that time, what is the bearing of the ship from the port? Okay, so let's see here. There's the ship. Here's the port. So we'll just kind of draw it like that. So I want you to think about that right there. That is north blank to the west. So we have to figure out this angle right here. So let's try to figure out and see what we got going on. Notice we have a triangle. This is 90 degrees. Okay. We could figure out this degree right here. I'm going to call it theta. If you look at theta, this would be considered opposite. This would be considered adjacent. So tangent of theta is equal to opposite over adjacent. So if we do inverse of that, we can figure out what degree that is. So let's see here. Inverse tan 11 divided by 7. So we get 57.53. So let's just leave it at the 5. Okay? So here are some things. I'm going to switch colors real quick. Okay? If this right here is 40, then I know from here to here is 50. So I need to figure out what's left in here. So I can do so because I know this is 90, then I know that that little bit left, I'm just going to subtract 50 from this, and I get 7.5. So I know that this angle in here is 7.5. Okay. You can also think of it as this 40 plus this 50 is 90. And I know that, no, I don't want to go that way. No, I like the other way better. That we know that here to here is 50, but I need to know from here to here. So therefore, I'm over 7.5. That's the best way to look at it. So I know that this is 90. So I'm going to do 90 minus my 7.5. And so I know that this angle has to be an 82.5 degrees. Okay. So let me know if you guys have any questions. The tricky part about these is making sure you understand what the word problem is saying and draw your north to south lines to get your picture correct. And if you need me, please let me know.